Hello guys, and welcome back to another programming video. Today we're going to be doing programming in Python, and we're going to learn about something called NumPy. NumPy is a Python module that allows you to calculate arrays and lists much faster than a normal Python code. So to install NumPy, you will need to first install Python, which you can get from python.org. Once you have Python installed, you need to type in the command in your terminal, pip install NumPy, all lowercase. And I already have it installed, so as you can see, requirement already satisfied. However, if you don't have it installed, you will see a very long line of code that tells you like its installation process. If this does not work, you can just go online, download a Python distribution, such as Anaconda or Spider, that has NumPy pre-installed that you can use. As soon as you've installed NumPy, you need to in the Python editor type in import NumPy to import the module. Usually, you can import NumPy as NP just to shorten up the code a little bit. So that's how to import NumPy, right? So next, let's start off with the NumPy version. That's just a quick way of knowing if NumPy is up to date or not. So print NumPy version. Let's run that. So it'll give you 1.18.4. So you should have the newest one installed. Just go online again, search up the newest version of NumPy, and you'll be good. So let's get started with calculation in NumPy. So and NumPy again is used to work with arrays, and the array object in NumPy is called an ND array. We can create an ND array by using an array function. So we will create a variable called myArray, and then mp.array, which is the creation of array, and then brackets. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have created a NumPy object array. This is different from a normal Python array, and we can do all the normal functions to it. Print my 1, 2, 3, 4, 5, 6, 7, 8, 9. Notice how this does not have commas in between. If you just do a normal Python array, it will print out the commas. As you can see, it will print out the commas. However, in a NumPy array, the commas will not be there. That is your first sign that shows that it is a NumPy array. So we can also use tuples in a NumPy array. So all we need to do is do same function, but now we use parentheses instead of brackets. And we can do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's print that. And as you can see, it still outputs the same as an array, but its type is a tuple now, and it again has no commas in between each value. Now we can talk about really quickly dimensions in arrays. I talked about this in a Java tutorial, I believe, though I'm not very sure. I'll have to go back and look. But really quickly, dimensions in arrays are basically nested arrays, where arrays are made inside of arrays. So a zero-dimension array is just one number or one value. So we can call a zero-dimension array 36. This is a scalar type, meaning that it's just set and there's no other values in the array. A one-dimensional array consists of just one pair of brackets and all the items inside. So right now, this is a one-dimensional array. Right? A second dimensional array or 2D array is called a matrix, and it's basically arrays inside of arrays. So what I can do is that I can create two brackets inside of this larger bracket and fill each bracket with items. And then I can also print the indexes, but you need to be careful right here. as you can see, in this larger array, we have 2 subarrays. And in these 2 subarrays, we have 4 items. So if we try to index this, let's say index 1, we print 5, 6, 7, 8. Because we are right now indexing the larger array, not each small array. To index each smaller array, we need to add another pair of brackets. Let's say in index 1, then we can call in index 2 from the subindex. As you can see, we print 7. This is the same for others. So we can have 3D arrays, which are arrays inside of arrays inside of arrays. So can create another pair of brackets and then just keep nesting each pair inside the other. So this is just some random numbers right here, so that there we go, perfect. So this is a 3D array. As you can see, there is the largest level of an array. Then there is then there is a smaller level of arrays, and inside of those arrays there are more and more arrays, right? So now if we print that, we get index out of bounds because this is actually not valid. So if we just do my array index 1, we print this whole thing, right? Because these brackets, as you can see, they're outlined, are a part of the first index in the largest array. Then if we do another one, we get 45, 354, and 65, which is the first index in the subarray, which is also the first index of the largest array. And then we can add one more number, and this should return 345, as you can see, because we're taking, first of all, largest array, then going in one step, and then going in another step. So with that out of the way, this is basically how to create multidimensional arrays in NumPy. So let's really quickly get rid of this. NumPy also allows us to check the dimensions of the array. So let's do array A, and this will be a 0-dimension array. Array B, that would be a 1-dimensional array. Array C, that would be a 2-dimensional array. And then we use the function, so I'll comment this. So function for dimension type, and that would be array name dot ndim, which stands for NumPy dimension list. So after that, I'm going to print that real quick. So print A dot ndim, print B dot ndim, and C dot ndim. Right, so that is done, and now if we run this, oh yeah, I forgot to do the np.array parts, because you can't use an np function on something that's actually not NumPy. So I'll real quickly add the casting over here. Here we go. Okay, that's done. Now let's run that, and we can see, what does that say? 1 dimension? Okay, yeah, it says 1 dimension, because we don't need those. There we go. Because as soon as you put brackets around an item, NumPy calls it a 1-dimension array. 0 dimension, so there we go. 0 dimension, as you can see. So I should just clear that real quick. Okay, so as you can see, there's 0 dimension, 1 dimension, and then 2 dimension. Right? If you want to learn more, you can always go to a Python tutorial, and then or go online search up multidimensional arrays. You can also create arrays that have multiple dimensions in NumPy. So we can do a variable called array for ARR, and just create a real quick basic one-dimensional array. There we go. And then we comma that, right? And then we type in ndim equals a number. So we can do ndim equals 5 maybe. Then we can print the array. I'm just quickly print that. And it says ndim is a okay. Yeah. Wait, what do we do? 3 real quick. So this ndim is an invalid keyword argument. That's weird. 1 second. Oh, there you go. And NDIM. Oh, there we go. Okay. Yep, it was a typo. And yep, there we go. Okay. So as you can see, this is quite interesting, right? If we don't use the ndim function, we get just a normal printout of a one-dimensional array, and again it says array dot dimensions what, right? But if we type in ndim, or ndmin, I don't know, but ndim, we then do 2. Well, we run that, it says 2, and it will automatically place these brackets to make it a two-dimensional array. So basically in NumPy, if you have 0 pairs of brackets in a code, that is a 0D array. If you have 1 pair of brackets, that is a 1D array. And if you have 2 pair of brackets in a code, that's a 2D array, and so on and so forth. So once you have told the code that the dimensions are 2, then it will automatically wrap another pair of brackets to make it a 2-dimension. So then we can just, we can do even 40. It should take a while to print. Oh yeah, so higher number. So it doesn't allow you to go, I believe, go above 5 to 10. So NumPy does have a limit to how much dimensions you can go. So what if we do 15? So 15 works, and as you can see, the code is adding on brackets. So now we have 20 pairs of brackets in here. Short, fun experiment. So 30. So I'm pretty sure it just goes up to 35, 33. Okay, so I think it goes up to 30. No, it is not. 32. 33. Okay, so the number of dimensions that you can specify is 32 dimensions maximum. So that's pretty fun. Now we can move on to something called array indexing. This is the same thing that I talked about when I was doing the dimensions tutorial. Basically, it is the same as using normal Python indexing, just brackets. You can do once, so that will import 2, so on and so forth, right? So that's array indexing. There's really not much else to it. However, in NumPy, you can do some really cool stuff with indexing. So we have an index of array 1 right here, so that's 2. If we plus array 3, so that would be 2 plus 4, that would be 6. So you can see it outputs 6, right? You can also, do this with higher the dimension arrays. Just make sure to specify each single value inside of the arrays, right? So next, moving on, we have something called array slicing. It's quite like normal Python. You just basically have an start value and have an end value, and the code will return the values inclusive of the start, but exclusive of the end. Okay, so just to demonstrate that, I'll get rid of that real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so there we go. we have a one-dimensional array right here, and we are going to slice it. So print array, and then from index 1, so it will start at 2 to index, let's just say 7, and index 7, right? So let's count 0, 1, 2, 3, 4, 5, 6, 7. Index 7 is 8, but it will only stop at 7 because it is exclusive of the index. If we just clear this, print that, as you can see, 2, 3, 4, 5, 6, 7, it stops at 7, however, it includes 2. You can also do something called stepping. So let's do 1 to, let's say, 6. So 0, 1, 2, 3, 4, 5, 6. So it will print out from 1 to 6, as you can see here. 1, 2, 3, 4, 5, 6. Let's try that again. Okay, so now we can step. So we just basically we have another colon, and that will be our steps. So basically, it tells you if we should skip over numbers. So if we do, by default, it's a step of 1. So if we enter step of 1, there will be no change. So step 1 means that you will visit every single number. Step of 2 means that you will visit every other number. 16, 1, 3, 5. So it will skip over 2s, the 4s, and the 6s. If we do number 3, or step 3, it will only print 1 and 4 because it skips by parameters of 3. And then if we do 4, so 1 and 5, because it'll skip 4 as it keeps going down the array. So that is array slicing. So to sum up, you have start, which is inclusive, end, which is exclusive, and then a step, which basically allows you to jump between numbers, right? So that's like basic array like structure, or like how to change arrays. So yeah, I hope this small tutorial helped. Again, this is basic. I'll do another part, so like more difficult NumPy stuff, probably like a few days after this video goes up. So stay tuned for that. If you enjoyed this, please subscribe, leave a like down below, comment what you want to see next. So for next video, I'll do NumPy. But after that, you can just tell me what you want to see. If you want me to try out something or answer any questions, I'll be happy to do that. So, yeah. Hope you guys have had a good day, and see you later.